Okay, in section 1, we learned how to graph. In section 2, we learned about functions. So now we're going to put them both together. Remember when we talked about this equation and we had a whole list of points that would fulfill this equation and make it true, right? If this is x, this is y. X plus y is 5. 1 plus 4 is 5. 0 plus 5 is 5. We could even go into the negatives. We could do negative 3 comma 8 is 5. We could do fractions. We could do 1.5 comma 3.5 is 5. It doesn't matter. Any two numbers, when you add them together, if they equal 5, they are solutions to this equation. Okay, now let's graph them and see what happens. Okay, there's the 3 that they gave you. One of the ones that I chose went off the graph, so negative 3, it's all the way up here. But this one, 1.5, 3.5, would be right there. And you can tell that they're all on the same line, right? I'm sorry that's a little shaky, but yeah, every single point on that line, when you figure out what its coordinates are, will add up to equal 5. There's an arrow on the end of both of them because it continues forever. We could use really huge positive numbers and then would have to have a really huge negative number to balance it out to equal 5. Okay, we could choose a really big negative number and I'd need a really big positive number to add to it to balance it out. So this is why, as it says here, they are called a linear equation because they form a line. So there are an infinite number of answers on that line because if I were to zoom in, I could do a point here and a point here, but if I zoomed in further, I could keep going and get more points in between those two, right? Plus, the arrow here at the end means they go on forever that way. There are an infinite number of solutions. However, you can't just say the answer is infinity because the answer has to be in the format of a point and they have to add up to equal 5. Okay, so here we're going to check and see, is this a solution to this equation or not? Is this a solution to this equation? In other words, does this point fall on the line when we graph this? We're not going to graph it yet. We could, but the way we're going to do it here is like checking. If this is x and this is y, let me actually zoom in on this one. Okay, I'm going to put those two numbers, this one and this one, over in the equation for y and x. Okay, so I'm going to end up with negative 9 equals negative 2 times, putting it in parentheses just to show that it's been substituted, plus 3. I'm checking to see if that equal sign really is true. Okay, so over here on the left, it's already done, so now let's figure out the right. So on the right, we're going to do order of operations. We're going to multiply first, and we get negative 6 add 3. Negative 6 add 3 is negative 3. So in other words, is negative 9 equal to negative 3? And no, it is not. Because it is not, excuse me, there we go. Because it is false, negative 9 is not equal to negative 3. Okay, so that means it is not a solution. Okay, it's a solution to something, but not this one, right? Okay, let's try the next one. Is 8 comma 0 a solution to that one? So 8 is your x, 0 is your y. So let's substitute them in. 0 is equal to negative 1/2 times x. I'm going to put it in parentheses again to show that it's been substituted. Add 4. I don't do parentheses over on this side because there's only one number. You could if you wanted to, but it's a little redundant, you know. Okay, so is this equal sign true? Let's find out. I'm going to put the 8 over a 1, and you can simplify. You can multiply straight across. I'm just going to choose to multiply straight across on this one. So negative 8 over 2 is negative 4. Negative 4 add 4 is 0. So this would come down, and 0 does equal 0. So that is true. So 8 comma 0, this point, is a solution to that equation. Okay? So you are looking to see whether it's true or false when you substitute it in. True means it is, false means it is not. Okay, so go ahead and try the 2 over on the right, the ones that are yours. Pause it, come back, and see if you got them right. Okay, here's your number 1. This is x, this is y. So we're going to have 5. We want to see if it is equal to negative 2 times whatever x is. It's negative 1. Add 3. Parentheses are also helpful when there's negatives. So if you just get used to putting a parenthesis, you'll have all your bases covered. So 5, does it equal negative 2 times negative 1 is positive 2. Add 3, and it does. That is true, right? So is it a solution? Yes. Okay, you don't have to write the sentence out that I wrote. You just need to put yes. That's the only answer you'll need. Okay, however, you do need to show all your work to get it there, right? Okay, number 2. So x is negative 3, y is 0. This is in a different format, so let's see what we've got. Negative 4 times x, and because I'm changing colors, I'm going to put them in here in just a minute. Okay, so our x is negative 3, and the y is 0. Is this equal? If it is, it's true. If it is not, it's false. Okay, so multiply these two, and add the answers. So the first one, negative 4 times negative 3 is positive 12. Sorry, it's jiggling. Add 0. Does that equal negative 12? No, it does not, right? 12 does not equal negative 12. Okay, so that was false, which means no, it is not a solution. Okay, so to figure out if a point is a solution or not, plug it in and see if you get something that's true or false. I write false in here so you can see. Okay, now we have a partial point. Okay, we have one value in the point given, and you want to find the other value that is a point on the graph. That's what it says, complete the ordered pairs for this. You could put any number in there and it would complete the ordered pair. But you want it to work for this equation, so it needs to be a solution to this equation. Okay, let's zoom in on this first one and I'll show you. Okay, so I'm going to rewrite the formula or the equation of our line over here so I have it to work with. Okay, this 0 is in the y position, right? So we're going to substitute it right in there for y. We don't know x, so we're going to leave it as x. So plus 2 times 0 and that is equal to negative 6. Now we're going to solve for the leftover variable. In this case, it's x. Okay, so here we go. Negative x, add 2 times 0 is 0, equals negative 6. Anything add 0 is the thing you started with. And now I have that invisible 1 there, right? So we're going to divide by negative 1 and end up with positive 6, which means x now is positive 6. Okay? I like to put the answer down at the bottom because that's where I'm looking for answers. So I'm going to rewrite it, but you don't have to. You could just fill in the blank. Okay, now on this next one, actually let me put the steps first. Hang on. Okay, so those are the 3 steps that you're going to be doing. Same thing every single time. It doesn't matter whether you're given an x or a y. Okay, so in this case, we have an x. In the last case, we have a y that's not a 0. We're doing zeros first for a specific reason because we're going to be using those later. So they wanted to make certain that you saw them up front. Okay, so I'm going to again rewrite the formula. That's just something you should get used to doing when you're doing anything because the formula is going to be on a paper, it's going to be on your screen, it's going to be someplace else. Make certain it's the first thing on your work paper so that you have it to work with and you don't have to look back and forth. Okay, so I'm going to leave x blank. I'm going to leave y in because that's what we're going to be solving for because we don't know the y, right? Okay, left x blank so I could fill it in with the color I used for x. Do I need the parentheses there? No, it just shows that it was substituted. Okay, negative 0. There's no such thing, it's just 0. So 0 add 2y equals negative 6. 0 plus anything is the anything, so 2y equals negative 6. Divide by 2, and we get y equals negative 3. And again, you could just write the negative 3 up top, but I'm going to rewrite the entire point down at the bottom. In Canvas, you'll just put it in the blank, right? Okay. All right, last one. I'm going to move the steps off the page, but I think you probably have them now. Okay, so again, I'm going to rewrite the formula. Let me move it back a little bit. So negative x add 2y equals negative 6. And we're going to substitute which value this time? X is missing. We know y. So I'm going to plug it in for y. So negative x add 2 times whatever y is equals negative 6. And y is negative 1. Solve it for x now. So we need to simplify. 2 times negative 1 is negative 2. And that negative becomes the subtract, right? So now we're going to add 2 to both sides. 2's cancel, leaving negative x by itself on the left. And we get negative 4 on the right. We have that invisible negative 1, so we're going to divide by negative 1. Those cancel, and we get x equals 4. So finish the point, we get 4 comma negative 1. Or, like I've said before, you can put the negative 4 up top. Trying to get it all to fit. Sorry. There we go. Okay, so if they give you one value of your point, you have to go through this process to figure out the other value. And what does that value mean? It means it is a point on the line, or it means this particular point is an answer to this equation. All right, now you have 3 over here with the new equation. Okay, so again, go ahead and do it on your own. Pause this, come back, and see if you get them right. I'm just going to write this across the screen on all 3 of them while you're working. And now I'm going to zoom in. Okay. Zeros, like I said, are used for other things that I'll show you here in a bit. Are there easier ways to do zeros? Yes, but I'm going to do it this way because this is what you're learning. Okay. So -3, what am I substituting this time? Okay, it is y, right? Okay, so that's going to go in here. So I do write the x. Add 4 times whatever y is equals 12, and y is 0. Okay, so 4 times 0 is 0. Everything else comes down. 0 plus anything is the anything. And now we're going to divide by -3. So x equals -4. Don't stop there. Remember, you have to complete the point. Okay, so complete the point. Like I said, I'm going to do it at the bottom, but you can just fill it in at the top. Okay, next one. This time we're given x, right? So x is going to go in here. -3 times x. I'll put a 0 in there. All right, so -3 times 0 is 0. Add 4y equals 12. And 4y then, because adding 0 does nothing to it, divide by 4, and you get y equals 3. Complete the point, and you get 0, 3. Okay, can you skip steps? Yes, but not every one. Okay, don't skip so many that you're making mistakes and you're not showing the important part. Okay, this step right here. Okay, we know that 4 times 0 is 0, and 0 add anything is the anything, right? So I would say that step right there is definitely optional. If you want to show it just because it makes you more comfortable showing every single step, that's great. If you want to skip any steps on this one, that's the one to skip for certain. There is another way of doing these, and I'll show you, like I keep alluding to, in just a bit. Okay, let's take a look at your last one. What are we given? Y. So it's going to go in here. So -3 times, times x plus 4 times whatever y is equals 12. Y this time is 2. So -3x add 8 equals 12. See, on this one, there isn't a shortcut because it isn't a 0. -8 on both sides, and we get -3x equals 4. Divide by -3, and we get x is equal to -4/3. Finish the point, and we get -4/3, comma 2. Okay, let me talk a second about this. I divided a positive by a negative, put the negative in the bottom, but here I put it on the outside. Okay, if you recall in another video way back, if I have the negative here, if I have the negative here, or if I have the negative out in front, these all mean exactly the same thing. Okay, the one with it on the bottom is the one you see the least often. You don't really want to leave the negative downstairs, so either move it up or move it out in the front. Okay, if you leave it downstairs, it's not wrong, it's just not used. So again, try to get used to not doing it that way. Okay, graphing. Here we go. I'm not going to do the actual graphing on this page. I'm just going to show you what this particular paragraph is talking about. The idea is you're going to be given an equation and you have to graph it. To do that, you're going to find either 2 or preferably 3 ordered pairs. Why is 3 preferred? Okay, so if I find out that one point is here, another point is here, and I draw my line between the two of them, that's great if those are both right. But what if one of them is wrong? Okay, if I get my third point is like right here, then that's absolutely fine. It was a double check. But what if my third point is over here? Then that means one of them is wrong. Okay, I'm going to assume in this case that one of the originals was wrong. So if the purple one was wrong, then here's the correct answer. If the pink one was wrong, then here is the correct answer. All 3 of those lines that I have drawn are completely different. And I can't say, oh, it's close enough. No, it isn't. Okay, you've got to be incredibly exact. So if you get this situation happening, okay, you've tried your 2 points, you drew your line, you try a third point, and it's not on the line, then do a fourth point. I know that might seem like it's extra work, but if your fourth point then is here, you know the purple one's wrong. If your fourth point is here, you know the pink one is wrong. If your fourth point is here, you know the teal one is wrong. You know what I mean? You just need 3 in a row anywhere. That's your double, triple, quadruple check, whatever you want to call it. Now we are getting to where we're going to be using the zeros. Where zeros happen in a point makes it either an x-intercept or a y-intercept. Okay, I'm going to move this off the screen for just a second and explain that. Okay, really quick graph. X-axis goes across, y-axis follows the tail of the y, and it goes up and down. Okay, so for example, if I had 0, 2, this means we're not going across at all, but we're going to go up 2, right? So that becomes right here. Those are really big. Let me fix it a little bit so they're the right size. If I have the 2 in the x position, then I'm going to go to the right 2, but I'm not going to go up or down. Okay, so I will be over here. Zeros make it stay on the axes. Okay, you get those dots. You get the I'm not going up or down. I'm not going left or right. I'm staying right here. Okay, so if you have a 0 in your point, it's going to be on one of the axes. And it will be on the axis for the position of the number given. Okay, so in this case, you're given y. So it's on the y axis. And on the second one, you're given x, so it's on the x axis. Okay, points on the y-axis are considered y-intercepts because it intercepts the y-axis. Okay, if it's on the y-axis, it's the y-intercept. If it's on the x-axis, it's called the x-intercept. This will have an x value and then 0 for y. This will have 0 for x and a number for y. Working with zeros is easier sometimes than working with other numbers because things cancel out. Okay, we're also going to use the y-intercept in graphing in a different type of graphing. This one, we're just going to use the x-intercept and the y-intercept to get to the graph. Okay, so what you're going to do in this case, let me include my graph in this. There we go. what we're going to do is choose x equals 0 and y equals 0, and we're going to find the other two values, and we're going to put these 2 points on the line, and then connect them. There's your line. You can do a third point if you'd like to double check it, but hopefully with the zeros it'll make life a little bit easier. Okay? Sometimes, as you see here, the y-intercept is a little far away from the origin or way up, and you need to have a bigger graph. Maybe that wouldn't be a point you want to try, but it doesn't matter. It's going to work. Okay? So here, the x-intercept, so we're looking for the x value, and we're going to let y equal 0. So for the y-intercept, we need the y value, so we're going to let x equal 0. Okay, so basically, finding the y-intercept, letting x equal 0, the x term cancels out, and all I have left is the y. When I'm finding the x-intercept, I want only x left, so I want y to cancel out, so I make it a 0. Okay, that may seem quite confusing because you haven't seen a problem yet, so let's take a look at a problem. Okay, here we go. We're going to graph this and identify the intercepts. Okay, it doesn't say that you have to use intercepts to graph it, but that's the easiest way to do it when it's asking you for them. Okay, so what I'm going to do, I'm going to do this one the way that you've seen. Okay, so I'm going to do one of them where x is 0 and I'm looking for y. And I'm doing another one where y is 0 and I'm looking for x. Okay, this is not generally the way I do it, but I want to show you first. So same formula, the equation for both of them. And I'm going to let x equal 0 here. So I have 2 times 0, add y. The 0 term cancels out, so I just have y equals 4. Put a 4 up here, and I'm going to graph it. 0, 4. It's right there. Because the 4 is in the y position, it's in the y-axis. It's considered the y-intercept. Okay. This one, the y is given as 0, so it's going to go in for the y. 2x add 0 equals 4. So you get just 2x equals 4, divide by 2, and I get x is 2. So that point is 2, 0. Put the dot on the graph and connect them. Do your best at drawing a straight line. OCD might make you get out a ruler or an edge of a paper or something, but the idea though is it should be straight on the same angle all the way through forever. Okay, so if I were to do, for example, connect these and then just kind of be lazy, that's wrong. Okay, you got to make it as close to straight as you can. I won't be incredibly picky, but that is incredibly lazy, you know? Okay, go ahead and try yours. And I will show you a shorter method of doing it, but I want you to try it this way first. Okay, here we go. I'm going to show you the easy way. In person, it's a lot easier. What I'm going to do is, because x is 0, I'm going to put a 0 in here, substitute everything in, rewrite it, and then 0 term is going to cancel out. Okay, I'm just going to do it and I'm going to erase it. Okay, so 0 minus y equals 4, and now that's not necessary, right? So all I have left is negative y equals 4. So instead of going through that entire process, I'm going to understand what 0 does, and 0 will cancel this out. So in person, I literally put my finger on top of the X because it goes away. Here, I'm just going to do that. On your paper, you're probably not going to want to because now I have to erase it on the next step. Okay? Okay, silly drawing, but here we go. I'm covering up the X, right? What I have left is negative Y equals 4. So divide by -1 now, and you get Y equals -4. Okay, another thing that you can do when you have a negative in front of the variable, instead of dealing with -1, think of if the opposite of a number is equal to +4, then the number itself would have to be the opposite of this. Okay, you want the negative here to cancel a negative here to give you a positive. So Y is going to be -4. This changes. Whoops, I didn't write the negative, did I? And this changes. Change both sides. Okay, let's take a look at this side. So this time I want to cover up the Y. The negative actually covers up with it because X minus nothing is just X. So you're done. X equals 4. Okay, so the points then become 0, -4, and 4, 0. Oh, that's crazy 4, sorry. 0, -4, 4, 0. Draw your straight line. And that's close. Okay, this is called the intercepts method. So graph this equation using intercepts. Boom, get your 2 intercepts, put 2 dots on a line, draw the line. All right, here's the next 2. But let me go over what that green paragraph says. Okay, zoom in and then I'll erase all of this and do the problem above. So if you get fractions for your points that are anything other than halves, Canvas freaks out. Okay, lumens. So let's say you were graphing the point, for example, 0, 4/3. 4/3 is 1 1/3. So we would not go over it all, but would go up to 1 1/3, right? So it should be right there. Because it's not on one of the halves, which would have been at 0, or 1, rather, sorry, 1.5 or 2, it will do one of 3 things. It will not let you put the point there, so you physically cannot make your cursor put it where it needs to be. Or you do it and it marks it wrong, or it will automatically move that point to whichever one you click closer to, and it'll pull it up here, which will mark it wrong anyway. Okay? So if you get something that has thirds or fifths or something and it's not on a half, when it simplifies, you've got to try a different value. Okay? I'll show you how to do that if it comes to that point. But right now, you're just practicing, so you haven't really learned it yet. So if you end up with those problems in your homework, let me know and I'll help you, okay? All right, so here we go. Okay, sorry that was jiggling around. Here we go. I've written it twice so that I can show you each of the different intercepts, okay? I don't generally do this, but it's kind of hard to show you without because you can't see what my fingers are doing, okay? So I'll try that differently on the next one. So if I cover up the X, it's going to look like that. It's not really covered up, but that little blue box is your finger. So you're covering that up, and you get 5y equals 0. Okay, so you can even do this in your head, and you divide by 5, and you end up getting y equals 0. So I let x be 0, and I got y equals 0. Okay, now over on this other one, I'm going to do the same thing, but I'm going to have y equals 0, right? So I'm going to put 0 in for y, and now you can see you're going to have to divide by 4, and you get 0 again. So x equals 0. This one can't be done this way, and that's why that little paragraph down at the bottom, okay? Because your x-intercept and your y-intercept are both in the same place, and that's at the origin. Okay, so you've graphed both of them. Now go ahead and draw your line. You can't, because there's not a second point to connect it to, right? Some of you could draw a line this way, some of you would draw a line that way, other people could draw a line here, and none of them could be right. One of them might be, but chances are slim. So you need a second point. And because of that, you have to choose a different value other than 0. Okay, so let's just choose anything you want. So let x equal 1, for example. If I let x equal 1, I'm looking for y. So if I put a 1 in for x, add 5y equals 0. Okay, I get 4, add 5y equals 0, minus 4 from both sides. And this is going to give me a fraction that is not halves. Okay, so that tells me at 1, it's negative 4/5, which will be about there. Computer won't like that. So what do I do instead? You have to be logical. Okay, so right here, I'm dividing by 5, right? So I need this number to be divisible by 5, which comes from here, which came from subtracting here. So I need this number to be divisible by 5. So what if I times by 5? Okay, so if I let x be 5, now I get 20, add 5y equals 0, subtract 20, and now it's going to be a whole number, well, a negative whole number, y equals negative 4. And now I can graph that. So 5 is going to be negative 4. Remember our other point was right there? It's going to go through that point. And, okay, you guys are going to laugh, but I literally have a ruler up against my iPad. See, it goes through the point that we wanted, but it's something that now the computer will let us graph. Okay, so back to the original, it says identify the intercepts. Okay, graph it. I did that. Identify the intercepts. There's only one. 0, 0. Okay, that's a weird one. Yours isn't that weird. Okay, here we go. Try yours. Okay, here's what I do. I'm going to put a 0 in for x, figure out what y is, and I'm also going to put in a 0 in for y and see what x is. Okay, so this little blue rectangle is my finger, right? So I cover up the x values. That includes the coefficient, even the negative. Okay, so what I'm left with is y equals 3. So that's my first answer. Now I move my finger over to, come on, the y part. And what I have left is negative 2x equals 3. Okay, so if I need to do that off to the side, I can, but divide by -2. So this gives you -3/2. And you can do that pink part in your head. Okay, -3/2 is -1/2, so it's going to be fine. It's halves. All right, so the teal one, 0, 3, is right there. The pink one, -1/2, 0, is right there. And then you draw your line. Maybe. Let's see if I can do this. Yep. Ah, nope. Sorry. Right there. Okay, so there's your line. And now it says, what are the intercepts? I have them. They're right there. Okay, an intercept is technically a point. It is the point where the line crosses either one of the axes. Okay, so if you say the y-intercept is 3, if it says y-intercept line, x-intercept line, you should technically put the points in there. And part of the reason to do this is so you understand which one is which. The x-intercept will have an x value. The y-intercept will have a y value. Okay, we have two forms of a line here in the middle. And the way that we just learned how to do things with the intercepts is using this form. We had x and y on the same side and it was equal to another number. So for example, I'm just going to make one up. 3x plus 5y equals 6. I don't care. The idea is x and y are on one side and they're equal to a number. That's considered standard form. This is the easy way of covering one number, solving for y, cover the other one, and solve for x. Okay, that's really easy. However, it's not really easy when you have slope-intercept form. And this is the form that you probably remember from learning this the first time through, whether it was last year or 10 years ago, y equals mx plus b. Okay, slope-intercept form is probably used more often when you're graphing. With slope-intercept form, it's not easy to cover this up, but it is easy to choose x values to begin with. You plug them in here and figure out what y is. Okay, that will make more sense when you see a problem. So let's take a look at a problem. Okay, here you go. All right, earlier in the class, we talked about t-charts and how they were going to come up. Well, here they are. This is an easy way of writing points that you don't have to do a point, comma, like this. Okay, so you choose an x value, anything you want. You plug it in, and you put your y value right here. And then you choose a new x value, and you put in your equation, and you put its y value right here. This becomes 2 points. You graph them over on the graph and connect the dot. To be absolutely certain, you do a third point. Okay, so let's start from the beginning here. I put in 0, 1, and 2 for x values. That's a good thing to start with. That's nice. Okay, if you end up with more complicated equations and you have fractions here, you'll want to choose different numbers that fit with your fraction. But in this case, it doesn't matter. Okay, so let's put in 0. So if I do, I will show you. I keep doing things without explaining. So y equals -3x add 5. And I'm going to put in x is 0. This is what I get, right? Okay, when I write it to show my work, I'm not going to write this. I'm just going to write this. So this is what it looks like. Okay, so I would do -3 times 0, add 5. And then when I get to the next line, I would do -3 times 1, add 5. And when I get to the next line, I would go negative 3 times 2, add 5. If you give yourself enough space, you can show the work under here if you need it. If you don't, you can just continue your work off to the right, although that's kind of frowned on in algebra to work the problem sideways. It's okay, because the algebra isn't the problem. Finding the points is what this problem wants. Okay, I'm going to squish this in underneath though. Negative 3 times 0 is 0. 0 add 5 is 5. Negative 3 times 1 is negative 3. Negative 3 add 5 is 2. Negative 3 times 2 is negative 6. Add 5 is negative 1. Okay, I have 3 points. Let's graph them. Pink one is 0, 5. Don't go over it all, but you go up 5. Purple one, you go over 1 and up 2. And the teal one, you go over 2 and down 1. Do those 3 lay on a straight line? And yes, they do. If they didn't, you would want to recheck something, or let me draw my line first since I have my straight edge over here that just moved. There we go. Okay, let's say the teal dot was over here instead, and you couldn't get all of them to line up on a straight line. You don't know which one, the pink, the purple, or the teal, is wrong, so do another point. So maybe do 3 over on your T-chart and see what you get. Okay, but we did them right, and there they are. Okay, number 2, we're graphing. First of all, it looks like a function, which it is. So what you're going to do, this is your y. Every time you see f of x, it means y. So if you don't like that, you could actually replace it and do a t-chart this way. Okay, x, y. Okay, because you have a fraction, you're going to want to choose values over in your x terms, your x column, sorry, that work with the terms in the equation. Let me explain. I'm going to do this problem. Okay, so we get negative 1/2 times whatever x is minus 1. X is 0. Negative 1/2 times whatever x is minus 1. X is 1. Negative 1/2 times whatever x is minus 1. X is 2. Okay, so here we get 0 minus 1 is negative 1. Negative 1/2 times 1 is negative 1/2 minus 1 is a mess. So I'm not even going to do this one if I don't have to. And here's why you don't have to. If I times by a number that cancels with the 2, I don't have to worry about a fraction. Now I get negative 1 minus 1, which is negative 2. So what would you choose over here for your next x value? It would not be 3, because 3 doesn't divide by 2. I'm going to choose either 4 or negative 2. Okay, 2 points is all you need, however. So I'm going to do 0, negative 1, and 2, negative 2. And now I'm going to determine which of those 2 purple numbers I'm going to need. If I do 4, it should be around here, and that's okay. If I do negative 2, it should be like right there, and that's okay. Sometimes when you choose a point, the answer will be off the graph, and so that's what I was trying to avoid. Okay, I'm going to show you both of these just so you can see what's happening. Okay, so negative 1/2 times 4 this time. 2 goes into 4 twice. Negative 1 times 2 is negative 2. Negative 2 minus 1 is negative 3. Over on my graph, I'm putting the point, and it does line up. Okay, so let's do the last one. 1 negative 1/2 times negative 2. And the reason I would do this one is because the negatives cancel. 2 and 2 cancel, and now the negative times the negative is a positive. So I get positive 1 minus 1 is 0. Okay, so negative 2, 0 would be right there. And I'm not going to use a straight edge, so if it's really wonky, I apologize. That's not too bad. Okay, it just said graph. So if you know for an absolutely certain that the 2 points that you did first were right, those two that I just erased, these two were right, do you need a third one or even a fourth one? No. But if you want to double check yourself, do a third point. I always do 3. It's just habit. Okay, here's 2 for you to try. See what you can do. All right, T-chart on number 1, x and y. Now remember, f of x is y. Okay, and I'm going to do 0, 1, and 2, just because that's what I like to do. When you get to more complicated graphs that are not just straight lines, you might want to do more points, but it's okay. All right, so we're going to do negative 0, add 2, which is just 2, right? Okay, now we're going to do negative 1, add 2, which is 1. Now we do negative 2, add 2, and we get 0. Okay, this stuff over here isn't necessary if you can do it in your head. However, this is an incredibly easy version. Number 2 isn't so easy. I wouldn't want to do it in my head. If you make a mistake on these, I can't see your work to see where your mistake was. So I would suggest showing your work. And I'm going to do these in the right colors, so hang on. All right, let's graph them. Pink is 0, 2. Purple is 1, 1. Teal is 2, 0. Oops, and I did pink the wrong color. Those landed in a straight line, so I'm good. And there we are. There's my graph. Okay, when you do it on Canvas, you'll put in a point. Let's say I start here. And then you'll have a line that shows up, and it's just in a random position, but it goes through that point. Once you put your second point in, then your line snaps into that position with those two. Okay? On paper, you're not going to have that option, so make certain you know how to do it without, because your exam is paper. Okay, this one. X, Y. 0 will work, but now I'm going to use 3, and I could use 6, but 6 is off my graph. So I'm going to use negative 3 instead, just to double check my work. Okay, and I'm going to write 2/3 times something minus 1 on every one of them. And again, this is because I'm using colors and it makes it easier for me. Okay, so the top one, putting a 0 in. 2/3 times 0 is 0, minus 1 is negative 1. Put in a 3. The 3's cancel. So I end up with 2 minus 1, which is 1. Or you could go off here to the side if that's too squishy. Put a 3 in. Whoops, sorry, negative 3, right? 3's cancel. So now I have 2 times negative 1 gives me negative 2 minus 1, which is negative 3. And I'm going to replace that one with a pink one. So 0, negative 1, 3, 1, and negative 3, negative 3. And those are in a straight line. Okay, when you're using Canvas to do your assignment with, it will not let you extend the graph past what they have printed. So doing a 6 for x and trying to get whatever this point is won't work. On an exam, you could definitely draw your graph out farther if you wanted to, but just make life easy for yourself and use the graph that you see. Okay, last concept, and then this video's done. All right, sometimes, okay, this page just looks crazy, I know that. Okay, I am going to move it off and explain it. There we go. So sometimes the equations will be only one variable. So for example, x equals 2. That's it. That's a line. Why? I'll show you. Okay. Do a t-chart. Choose a value for x. You can't choose 0 because it says x is 2. Okay, so that doesn't work. Can I use 1? No, because it says x equals 2. So I have to use 2. So what's y? Choose a second point. Choose a third point. It doesn't tell you what y is. So y can be anything you want. 0, 1, 2. I know, that's weird, but let me show you. Okay, so I'll go back and do them in colors so I can refer to them. 0, 1, 2. So the teal point is at 2, 0. The pink or purple is next is at 2, 1. The pink one is at 2, 2. So what's happening? It's making a vertical line. Every single point on that line has a x value of 2. Okay? Might be a fraction, might be a decimal, but every single one of these is 2 comma something. Okay? That's what this says. X has to be 2, but y can be anything, or is everything, basically. But it can be anything for the points that you're graphing. Okay, so an x-only equation becomes a vertical line. So what do you think a y-only equation is? Yeah, it'll be a horizontal line. But let me show you why. Okay, so x, y. Choose a value for x. What is y? Negative 3. Choose another value for x. What is y? Negative 3. Choose another value for x. What is y? Negative 3. Okay, so rather than erasing, I'm just going to make these into colors. So no matter what x is, y has to be 3 every single time. So graphing those now, 0, negative 3 is down here. 1, negative 3 is here, and 2, negative 3 is there. So it becomes a horizontal line. Yep. How do you keep those straight? Okay, I'll show you. If it's an x only, it's going to cross the x-axis and not the y. Okay, so it crosses the x-axis. It doesn't cross the y-axis. It crosses x because there is an x. Okay, so it has to be up and down. It parallels the y-axis. Because this equation is y equals, it's going to cross the y-axis and never x. Okay? So only x means it will only cross the x-axis. Only y means it will only cross the y-axis. Okay, so now let's go back up top. Okay, so graph and identify x equals 4. It will only cross the x-axis at 4. There it is, up and down. Identify the intercepts. This is the x-intercept, and it is at 4, 0. And the y-intercept does not exist. There is none, because it doesn't ever cross the y-axis. Okay, this one. Y equals -1. Y is the only thing that's there, so it's only going to cross the y-axis. So it's going to cross the y-axis at -1, and every single point is going to have -1 for the y value. Okay, so what is the intercept? The only one we have is the y-intercept. So it's 0, -1. And there is none when it comes to the x-intercept. Okay, now this one isn't in the right format yet. Okay, x minus 3 equals 0. Great. Let's add 3 to both sides. Okay, so add 3, and we get x equals 3. So that means all of your x values have to be 3, and y can be anything you want. Choose 3 numbers. Or you can just recognize that x equals 3 means it crosses the x-axis at 3 and will never cross the y-axis, so it has to be vertical. Okay, but those points that I put in the t-chart are this one, and this one. Okay, just because the t-chart is printed doesn't mean you have to use it. If you know how to do it without, do it without. Okay, answers down at the bottom. X-intercept, y-intercept, which one do we have? It crosses the x-intercept, so we have, or crosses the x-axis, so we have the x-intercept. Does not cross the y-axis, so we have none. Okay, that does it, guys. This was a little bit longer, but there's a lot of details that you needed to know. It's just not hard, okay? You've got this.